Good morning. My name is Dr. Cartegna. I'm here with my honors physics, block B1, and I'm here to go over with them the data that they found from a lab that they performed where we took a plastic spoon. We taped that plastic spoon to a desk. We put a marshmallow on top of the plastic spoon, and we put it up in the air and let it fly. And the purpose of the lab was to determine the spring constant that's in this plastic spoon using concepts related to conservation of energy, right? That was the whole lab. It was performed, I guess, a week or two ago, and now their data we have up on the screen. I don't know how well you're going to be able to read it, but I got their data from their lab reports, and I made a copy of each of their data sections and distributed to all the groups. And now what we're going to do is ask each individual lab group questions about their data to defend what they found with their spring constants. So I'd like to pan out now to the classroom, and we're going to choose a group to start randomly here. So let's see. The first group will be Anna. All right, so group one was randomly chosen, and Anna in particular. And during this lab, we had to make a bunch of conversions, right? And so I'd like her to address and defend those conversions that her and her group made.
So we had to find the gravitational force first. So we found the mass and height, and we multiplied mass times gravity, which is 9.8, and height to get GPE. And then we did GPE equals EPE, which is spring constant, right? And to find the energy.
Okay, good. And does anyone else in the group, specifically about more conversions that you had to make during this exam?
For mass,
during this lab, rather?
For mass, we would convert grams to kilograms by multiplying by 100.
Okay.
And for meters, we would convert centimeters to meters by multiplying by 100.
Okay, and why did we convert grams to kilograms, and why did we convert centimeters to meter? Why did
Because
that?
for mass, the unit is kilograms, not grams. And for height, the unit for it's meters, not centimeters.
Very good. Okay, very good. Okay, we're moving on to group two. And group two, I looked at their data, and I noticed that they chose two types of potential energy to conserve. One was gravitational and one was elastic. And my question to that group is, why would you have selected those two types of energies for conservation? So I'd like them to respond and defend that.
Okay, so we use GPE because there's always gravity pulling down on something, and gravity is always 9.8, and with the spoon you're bending it down and gravity's pulling it down.
Okay, can we add to that?
And then we use EPE because it's elastic potential energy. So we're trying to measure the spring constant of the spoon, so like the elasticity of the spoon. So that's why we have to equal gravity to the elasticity, which is EPE.
All right, so and EPE then stands for elastic potential energy. And where do you find elastic potential energy typically?
In things such as springs or things such as spoons, anything that can like move like with like a I don't know what's the word, like when you stretch it out and it comes back.
Okay, yeah, so it has a recoil to it, right? And as far as gravitational potential energy, where would we experience gravitational potential energy or GPE?
Anywhere, kind of, where something's moving or in the air, like off, like lifted.
Lifted, meaning it has what associated?
Height.
Height, yeah, height. Okay, very good, thank you guys. We're back again with group three, and I guess the question I have for them is, when they presented their lab report to me, they gave me an equation of K equals 2 mgh over x squared. And what I did is I went around the classroom and I looked at all the equations that we have posted, and for the life of me, I could not find that one equation anywhere in this classroom. So I need to ask them, the question is, defend that equation. Where'd you get it from? Did it fall from the sky? Tell me how it came about.
We put together the two equations for GPE and EPE. So GPE's equation was mgh and EPE's was half kx squared, and then we isolated the variable k.
Isolated the variable k, good. Victor, why did you go ahead and isolate the variable k? Why is k so important to us?
So the only reason we isolated the variable k is because since the lab is about finding the spring constant of a spoon, k, which is spring constant, we needed to isolate it because that's what we needed, and that's what we did.
All right, and this group went the extra mile by selecting two objects, not just a marble, but in addition, they not just the marshmallow, but they also did a marble launched off of it. And what would you expect to see when you came up with the spring constants for both of those objects?
They would both be similar.
They would both be
since they're
similar.
constant.
Since it's a spring, very good. And were they
Yeah, they were similar.
similar? They were off by a little bit. Any reason why you think they could have been off by a little bit?
Because in each lab, like, there could be different errors that could occur.
Okay, very good. Thank you. All right, so we're here with group 4, group 4. And what they did is they submitted their lab results, and they gave us a spring constant of 32.732 Newton meters. And my question to this group, and I'm asking them, defend that spring constant. How can you be certain of your accuracy?
Alright, so we repeated the trials over and over again. So we weighed the marshmallow 3 times. We flicked the spoon 2 times to make sure we got the height at the same point. And we made sure that when we put the tape on the thing, it was there and we measured it perfectly.
Can we add to that at all?
I think he covered it.
You got it?
Yeah.
And how about your equations? And did you verify that you isolated variables correctly?
We made sure that we had the right numbers and that we multiplied and divided to get our true answer.
Okay, well, thank you very much. All right, so now we're back again with group 5. And the question I have for them is, after we looked at all the data that was submitted and spring constants, I'm noticing that there are 6 different values for the spring constant. Everyone used the same spoon. All identical spoons, all the same amount of bendiness to it. How is it possible that we got 6 different spring constants for the same spoon? Please defend that.
The reason why the answers were different because the force that was applied to the spoon may have been different in every group, and maybe when we weighed the marshmallows, they were a little bit heavier than others or lighter than others, and that's why all 6 different answers.
You mentioned about the when you weighed the marshmallows, when you massed that, and it could have been different. How could you eliminate that then? How could you reduce the chances that the masses, you got different readings for masses? How could you eliminate that in the future?
I think...
Help them out, guys.
Yeah. What do you think?
You can make all the marshmallows weigh the same
How?
by measuring them, and if you need to adjust them, you can cut them.
Good, okay. Any other comments about that spring constant, how they could vary from group to group?
No.
The height in which you pull the spring back, the spoon back.
Very good, very good.
Maybe we started at a different point in the meters. Maybe we started with different measurements from the beginning.
Okay, and that distance that you're pulling your spoon back, what's that?